So speaking of GIS products, of course, we cannot not talk about KMI since we have our own software. And in this video, you can see how to automatically convert different coordinate systems and import imagery from Google Maps directly into KMI environment. All you really need to know is the coordinate system you're working in. You can select the boundary of your area of interest using the built-in geocalculator, recalculate the coordinates of the boundary points, and then load the corresponding Google Maps tiles. You'll notice that the system includes a long list of coordinate systems. By entering the system ID into the filter, you can quickly find the one that you need. The world map below shows the boundary of the selected zones in white, and you can drag frequently used coordinate systems into your favorites for easy access. And if needed, you can also adjust map display and switch between satellite and road map views. Coordinates can be imported and exported in CSV and KML formats, which makes it easy to integrate external data into your workflow. And together, the coordinate conversion tools and Google Maps integration provide a powerful way to analyze project data. In fact, this functionality has helped us tremendously to avoid serious mistakes in resource estimation. It has even supported geologists and legal teams working at operating miles. For example, one time there was one case involving a titanium deposit. The mining license listed a large area and significant tonnage. However, when we analyzed the spatial data, we discovered that the part of the licensed area was covered by pine forest and lay within protective reserve, and mining permits for that zone were denied, which restricted development required part of the resources to be excluded. So because this was identified early, the team was able to amend license in time and save substantial cost in future mineral use taxes. Similar situation actually occurred at one of the iron ore quarry. The long-term mine plan showed a pit outline extending into protected zones that included railway line, station, and regional gas pipeline. And these facilities were not reflected in the original layout as they lay beyond the short-term planning horizon. So we recommended contacting the railway authority to explore relocation options, but the request was denied, making it clear that the mine development strategy needed a fundamental revision. Another case involved Google Maps imagery at a graphite operation, and the satellite images revealed overlap with a cemetery, a sports stadium, and residential housing. So addressing these constraints would have required major investments, including, let's say, water management, housing compensation, cemetery relocations. So when all of these factors were included, the project actually was found unviable. So we've encountered many situations like this in our practice, and that's why the value of integrated Google Maps tools with dynamic scaling and coordinate conversion is very clear. They help identify spatial constraints early, reduce risk, and support more realistic and defensible project decisions.